Now, into this, we'll be building a smart contract that enables us to store student record. Then, with the help of students, with the help of the address or with the help of a student address, we'll be able to obtain their record. And we want to ensure that not just anyone is allowed to access the address. Only a verified set of people are allowed to have access to a student record. Imagine now, like we have an academic institution, so like the set of people that are allowed to have access to a student record or information can either be the student, or maybe the class teacher, or the school founder. So those are the people that will be allowed to, have access to the student record now. So now our problem statement is this now. So as I said in our previous edition, I said before you start writing your smart contract, or before you start writing your Solidity code, you must first tell the Solidity compiler the Solidity version you will be using. And as I said, to the keyword that enable us in achieving that is the pragma solidity. Pragma solidity automatically tell the Solidity compiler that we are interested in, so that it's telling the Solidity compiler of the Solidity version we want. So now after inputting the pragma solidity keyword, all you just have to do is input the Solidity version we are interested in. Then at the end of each line of your Solidity code, you must always remember to put a semicolon, because if you don't put a semicolon, Solidity will actually definitely throw an error. So now we've put input our Solidity version here, and we can actually see that Solidity is still telling us that the Solidity compiler is still throwing an error, or that so the error is still relating to the Solidity version. So now, as I said, the Remix IDE. So now the Remix IDE also give us comes with an interface that enable us to set the Solidity compiler or the Solidity version we are interested in. So now, here now in our code itself, we specify that we are interested in Solidity version 0.8.0. But now, if we should go to our Solidity compiler, the version that we are currently selecting now is 0.8.0. Now, the version we select in this the version we will specify that we want to use is 0.8.0, and the version that the Remix ID specified that we want to use is 0.8.7. So now there's a kind of conflict between the Solidity version. So now for us to resolve this error, we either put the arrow symbol. So, and don't forget, we also said there are different ways in which you can specify the Solidity version we are interested in. So one is we can specify the version is okay. We can tell Solidity compiler that okay, we want version that is starting from 0.8.0. Now if you realize the red underlining is completely gone, because this arrow that we just assigned is basically telling Solidity that the version we are interested in is Solidity version starting from 0.8.0 and above. That is, if it sees 0.8.1, then Solidity compiler is satisfied with it. 0.8.2, Solidity compiler is satisfied with it. So now, but in this case now, we are just interested. We don't want to create a range of Solidity compiler. All you just want to we want to narrow down the version we are interested in. So now to fix this error, we go to this compiler section, we search for the version we are interested in, we click on it, then save. Now that should actually go, but so no. So now, as I said, to resolve this conflict, we need to step down the Solidity version that we have, that our remix ID have selected itself. So now we need to click on 0.8.0, then click on save, then waiting for my code to compile. Now you can see the error is gone. No more error in my code. So now we also talked about licensing of our code. So the licensing is just basically like it tells how a specific code will be used. So that's just what licensing is meant for. It's just like guide how a specific code can be used. So now for us to specify the licensing of our code, then you put two slash, then SPDS license identifier. Then this SPDS license identifier um keyword, I'll just say it's also like a keyword like that tells Solidity, okay, we want to specify a specific license for this code. Now it is after these two semicolon that will then it is after these two semicolon we then tell Solidity the license we are using. Then for our code, the license we'll be using will be MIT. So now actually you can go further, make more research, learn more about what licensing is. But for this specific edition, we'll just be using the MIT license. Now let's go into what our code is. So now first actually during our last class, I know because for people that are already coming from the Web2 background, they already know what comment is. But now I would just like to introduce comment to people that don't really have experience from the Web2 background. So basically, what is comment? Comments are basically a symbol that tells Solidity, or that tells the Solidity compiler to ignore a specific ignore a specific aspect of the code. That is, comment basically enables us to add useful information to our code, like and like now. So now in our case now, so now for you to write a comment, you just use the help of the two slash. Then once this Solidity see this two slash, it automatically understand that, okay, what you are basically having in this line, that it is a comment. Sorry for the crack in my voice, and sorry for that. So now once Solidity compiler see the two slash, it automatically understand that what I'm seeing here is basically a comment. Then it does not bother compiling the code. So now, as I said, comment enables us to write useful information to our code. But as we move on in the tutorial, we'll learn more how to effectively use comment in our code. So it also help boost the readability of a specific code. Now, in this case now, so we basically can write comment in this way. We have a one line comment that is just item that is written in a specific line will be ignored, and we also have like multi-line comment, that is it enables us write comment in just more than one line. So now to tell Solidity that we are having a multi-line comment here, then it is you input your two slash, then you put your two star, then with this whatever that is written between this whatever that is written between it, then Solidity automatically ignores it. It does not compile it. Now our problem statement today. So as I said, what we basically be doing, we basically want to use the knowledge we've gathered in the previous edition to build to practice what we have learned. So now we basically want to build a smart contract that enables us to store student information. So now we are building a smart contract that enables us to one store student information, to retrieve student information, three delete student student information. Then so now So after we want to create a smart contract that enables us to store student information, retrieve student information, delete student information. Now, the way we now want our smart contract to behave is that we don't just want everybody to be able to what to be able to delete student information. We don't want just anyone to be able to what to be able to retrieve student information. So now we'll be creating like an and we'll be creating like an administrator that will be in charge of adding information, deleting information. So now, we'll be creating an administrator that will handle delete, delete, retrieve, and all that. So that is why. So that is the role of the administrator. So now we are done with forming. We are done with creating our problem statement. So now let's go into writing our smart contract that enables us to, that enable us to achieve this. So let's now start writing our logic for our contract. So now, as I said, where your code lives, where all your logic live is inside this contract. A contract just basically acts as a container that holds us our contract code and all that. So now to start writing our contract, we declare the contract keyword. Then what will be the name? Then the name of our contract will be um, student student data student database or something like that. So student database. Now we said we want to create a contract where we will have an administrator. Now we are going to create a variable. The variable name will be an administrator, and the variable type will be an address. So as I said, we've looked at various data type. We look at the reference data type, and we look at the reference data type. So now let's now declare our administrator variable. So now first in Solidity, as we said Solidity is a statistically typed language, and when we say something is a statistically typed language, that is before any when we are declaring any variable, we must inform Solidity the type of value that will be stored in that variable. Are we storing a number? Are we storing an integer? Are we storing an address? So we must always inform the Solidity of what type of data type we'll be storing in that variable. So that is what we mean when we say a programming language is statistically typed. So now the way with the syntax in which we're doing that in Solidity is tell Solidity the data type. Then after declaring the data type, then we now put after we say we've written the data type, then you now add what will be the variable name. So in our own case, our variable name will be what? Will be administrator. Admini Spelling of administrator be correct. So now, as I said, at the end of each line of your code, you must put a semicolon. It is a rule in which Solidity, it is a rule, it is like just like a normal standard in Solidity. So now, you now want to keep count of how many record we've added so far in our how many record we've added so far. So now then we now want to declare another variable that is named count. So now we are declaring a integer. So and the integer we are declaring now is now a what, an unsigned integer. Don't forget we said we basically have two type of integer in Solidity. We have the unsigned integer and we have the signed integer. The unsigned integers, we can only store positive number in them. The number that we can store in them are 0, 1, 2, and 3. And we also said the unsigned integer itself, it has various versions. We have unit 8, unit 60, unit 8, unit 16, up to unit 256. So that is the various version of the unsigned integer. So now our variable now we'll be naming it count. So now since our initial count, we'll be initializing it. So our initial count will be what? Will be 0. So currently we've not had any we've not had any record yet. So now we'll also be creating a struct. As you said, a struct is just like an object in for those coming from the Web2 background. A struct is just like a represent like an object. A struct is like an object. Like if you are coming from the Web2 background, Web2 is like an object that enables us to represent a specific item. So now the struct we'll be creating in this will be to to like represent each student in a class, and the way in which we declare a struct is with the help of the struct keyword. So the struct keyword informs Solidity that we want to declare a struct here, and what will be the name of our struct? The name of our struct will be what? The student info, then two you put the bracket. So now we now need to tell Solidity each what because this struct will contain various property. Now we now need to tell Solidity what data type will this property be. So now if we are creating a student struct, or if we are creating a student object, and an object basically contains information about a student. So now what are the information we want to store about a student? Now let's say age. So now age, then declare your data type, then your put the name of the short property after you inform Solidity that this is the type of data this particular property will be holding. Then you put your so when you are done, you put your semicolon. Then after that, we'll be storing the student name, and in this case, if you are storing the student name, then it should be a string. So now it should be a string. We are storing the student's name, the age, the date of birth. The date of birth also will be a string. Date of birth to be a string. Then what again? Let's say um comment comment also will be a string. Is the student a bad student? Is he a good student? All that. So or let's say call it teacher's comment. Teacher's comment. So now we've been able to successfully, create a struct. Now let's move further to create a mapping. So now to create a mapping, we declare to create a mapping in Solid. So now the way we've actually talked about mapping. So in our previous video that we created, you can actually go back to the video so that you can learn more about these various data types we are making use of. All I'm just doing is I can't really give a full details about these data types. So I can't really give a detailed explanation about these data types we are using. Now, as I said, you can just see a mapping as something that have like a key value pair. That is, with the help of a specific key, we can look up a specific value. That is how you just see the mapping. And the mapping, the struct, the arrays, their data types that fall under the reference type. So, and the likes of the address, the unit, their data types, they are, they fall under the value type. And we also talked about the difference between this reference type and the value type. But for the reference type, if you are using them as a local variable, you must actually specify a storage location for them. We actually did a deep dive into all this in the previous episode, so just try and uh look at the previous video that we did, so you can get a full understanding on how these various data types, so that you can get a full understanding of how they work and why we are using them the way we are using them. Now, to declare a mapping, so the we declare mapping with the help of a keyword that is called mapping. Then, so now we now need to specify the key, because we said mapping, it just enables us to create a key value pair, or let's just say like a table. So now with the help of a specific key, we can look up a specific value. So now so in the right hand, so in these two brackets we put here now, we now need to specify the key now. So, and don't forget, the key will always fall under the value type. So any data type, we do not use the reference type data type as a mapping. We don't use the reference type data type as key for mapping. So the only data type that are allowed to use as key for mapping are the value type data type. They are the only ones that are allowed. They are the only one that are allowed. So now, so what will our so now for this now, what we just want to do now is, let's make use of an address. Then address, our our key will be an address. Then our then the data that will be our key, and our value now will be of the struct data type that we just create. So now we can now specify the name of the mapping. So now you can just say student, um what should we name it? I'm kind of bad at create coming up with names for like a variable. So I'm just trying come up with something nice. Let's give it, what name should we use? Um let's use, okay, address to records. Okay, let's use student records, because you are storing all the student record in this mapping. So now we've been able to successfully create an administrator variable. We've been able to create a count. The count enables us to keep track of how many record we've been able to add in our mapping. We've created a struct that handles a struct that enables us to create information about a particular student. Then we look at a mapping just like having a key value pair, a kind of like key value pair. So with the help of a specific key, we can obtain the a specific value. That is what a mapping does for us. Now let's now go into further. So we said the contract should be able to what, to store student information. Now let's go ahead and create a function that enables us to what, to store student information. Now, before we proceed, we said we don't just want anybody to store information. We don't just want anyone to retrieve information. We don't just want anyone to to delete student information. So, and we also want to create an administrator. Now, to now create an administrator, we have a constructor. So a constructor is just like a constructor is like is native to Solidity. That is, it comes with Solidity. So let's create a constructor. So now, what are constructor? Constructor are like functions that come with Solidity. So now, this function, they are special kind of function. They get called once, and the points at which this constructor function get called are the points in which we deploy our code to the blockchain. So that's when these constructor are called. So immediately our code is deployed to the blockchain, that is when this constructor get called. So now, so this with the help of the way this constructor behave, it enables us to create something like a owner of a specific smart contract. So now, for this our case now, we will be initializing our administrator variable inside this constructor. So now, we'll be initializing this our administrator variable inside this constructor with the address of the person that is what, that is deploying this smart contract. Also, we also have something there are also some global variables also that Solidity that comes with Solidity also, like this message dot sender now. This message dot sender is basically referring to the person that is currently interacting with the smart contract, like the address of the person that is currently interacting with our smart contract. So the message dot sender enables us to get the address of that person. So as I said, the message dot sender is a global variable that Solidity gives to us. It enables us to have access to the address of the person that is currently interacting with our smart contract. And I also said the constructor is a special function that comes with Solidity, and the constructor get called when our code is once, and the point in which this constructor get called is when we are deploying our code to the blockchain. So now we've been able to successfully set a constructor. Now let's move further to write our store student information function. Now, store student information. Now to declare a function, we declare a function with the help of the student keyword. With the help of the student keyword, then you put, then now we want to declare this our function. We declare a function with the help of the function keyword. Then after writing the function keyword, then you write the name of the function. So in this our case, the name of the function will be store student information. So now, after you store student information, you need to specify the visibility of your function. Don't forget, in our previous article, in our previous lecture also, we also we talk about visibility. And as I said, visibility is basically how we can see visibility as the how a specific variable or function can be accessed. So it's just like a permission, just like telling Solidity if a specific function is allowed to be accessed within a smart contract, or a specific function is allowed to be accessed outside the smart contract. And don't forget, we have various visibility. And when we say visibility, visibility are basically keywords. They are basically keywords in Solidity that enables us to tell Solidity if a specific function or variable can be accessed within a contract or outside a contract. And we have about four type of visibility. We have the public, we have the external, we have the internal, we have the private, we have the public, the external, the internal, and we have the private. We also talked about how these various visibility, how they behave in our previous lecture. So now for this case now, our store student information, because now because the administrator will be accessing this function outside the contract. So now we need to mark it as public. So now once a function is marked as public, then that function can be accessed within a contract, it can be accessed outside the contract. So now let's add our public, then you put your curly bracket. So now we've been able to successfully what? We've been able to successfully create a function that enables us to store student information. Now let's start writing all the logic. So now this function now, so now as I said, the way we want to implement our function is that we want to ensure that it is only the administrator that is actually calling this function. So now how do we do that? So now the way we implement that is we use there's another function that comes with Solidity, like a function that comes with Solidity that enables us to perform a check. So now, and the name of the function is what? Is require. So it enables us to check. So now, if the argument, so now, as we said, we want to ensure that it is only the administrator that is. We want to enforce. We want to ensure that it is only the administrator that should be able to what call this store student information function. So now Solidity comes with two important function, which is the require and the assert. So we have require and we have assert. So these two function are very important function. As a developer, you definitely going to use it in your day-to-day activities. So now what's the difference between this require and what's the difference between these two assert? Now once so a require enables us to check if a condition that we pass to it is true. So if the condition that we pass to the require is true, then the require will not throw an error. Then the function everything will then the function will continue to work as usual. But now in the case whereby the condition in which we pass to this require, in the case whereby it is not true, is going to cancel execution, and the require function will refund all the gas that we've paid to execute this type of transaction that is going to cause state change. Don't forget, whatever operation that performs on the blockchain will require whatever operation that will cause state change will definitely require gas, because updating state of the blockchain does not come for free. All these things require it require the help of a miner, and this miner that are helping us to update the state of the blockchain, they are carrying out a series of computation. This computation, they are energy intensive. So once something is energy intensive, at least they need to get reward for what they are doing. If not, we might end up nobody. It's just like an incentive just to encourage them, so that so that they can continue to know to help participate in the network and participate in the updating of the blockchain state. So now, as I said, the require function is an important function. It enables us to validate if a specific condition is true. Then if a specific condition is true, then the code will continue to run as usual. But if the condition is not true, then it automatically cancel execution, and it return this error message in which you put here, which is only student is allowed. Only so it will now return this error message: only administrator administrator only administrator is allowed to call this function. Then so now let's look at the second statement. The second statement too works the way the assert also works the way in which the require function work. But the difference between them is once the condition that is passed to the assert function, once the condition passed to it is wrong, then definitely is going to use up all the gas that we've paid to to execute this function, and it's not going to refund those gas. So but for require, once the condition passed to require is false, then require stop execution, then it will refund the gas that we've already paid to execute this function. So now it is more advisable to now use require when we are performing stuffs like validation, condition validation, error handling and all that. So it is more economical to use it, because if we use assert to me, it's just like it's going to waste gas. It wastes gas, while require it help us saves gas. So that is one importance of using the require over the assert. Now let's go further into the tutorial. Now our function store to student information with carry out the condition to ensure that okay, it is only the administrator, so it is the administrator calling this function. So if it's not the administration calling the function, then definitely the require will throw an error that only administrator is allowed to call this function. So now let's now so we want to store student information. What are the student information that we need? So now we need the student name. So now urine. So we need the student age. We need the student age. Now we need the student age. Now we need the student age, we need the student name, and the name in this case is what? The name is a string. Now you realize that the Solidity compiler threw an error saying that data location must be memory or core data for parameter in this function. Now, as I said, we've previously talked about storage location. We said we have two type of data type. We have the value type and we have the reference type. So now when we are using now we have the value type and we have the reference type. The reference type, when we are using them as a local variable, that is when I say local variable, that the local variable are variable that are used within a function. So these are what I call local variable. They are variables that are used within a function. So when we are using the reference type, we need to specify the a storage location for them. So and don't forget, we said we have three type of storage. We have six type of storage location, but for this course, the one we are interested in are the memory, the storage, and the core data. So now, if the data types that fall under the reference type data type are the struct, the mapping, and array, then we now said a string is a special type of an array. So now, if a string is a special type of an array and array fall under the reference type. So now, if you are now using the array data type, a variable type that fall under the array type in the function. So now, since it fall under the reference type and in the reference type data type, we need to specify storage location for them. So now that is why Solidity is now giving us an error here that now we are using a reference type variable, but we've not specified a storage location for them. So now for us to now fix this error, let's use the memory storage location. Now you can see the error is gone, no more error there now. So now let's move further and let's create another argument. So our date of birth, which is a string, then memory, Then the next argument there is teacher's comment. So the teacher's comment is also a string. Then we are storing it in memory, and we are the name of the argument should be teacher's comment. Then use hyphen. Is it hyphen or underscore? Man, forgetting all this stuff. But sorry, just accept it like that for now. So now we've been able to successfully pass so now we've been able to create arguments for our function. Now let's go ahead to store our our data in our let's go ahead to store our data in our mapping. So now to store our data in our mapping, first we now need to create a student object. As I said, a struct enables us to create an object to represent a specific item. So now it's time to store our information in a mapping. So before we store our student information in a mapping, we first need to create a student or a student object from the struct in which we declared previously. So now, as I said, this struct now is just like a blueprint on how the struct this struct now, this declaration we just did here now is just like a blueprint on how the object we want to create from this struct on, or it is how the object structure will look like. So now it is now time for us to create an object from this struct. Now to create an object from this struct, then copy the struct name. After copying the struct name, you come down, paste it here. So now we now need to store. So now we want to store whatever object we'll be creating from this struct into a variable, and the variable will be of the type this struct that we create also. So now now let's now declare a variable, create new student information. Then so now don't forget we said the struct fall under the reference type data types, and once the reference type data type are used as local variable, we need to specify their storage location. So now we need to specify the storage location for this struct variable now. So now our storage location will be memory. So now to now create an object from that struct, you paste the struct name, then you will now follow the order in which the struct in which we structure the item in the struct. So now in our in this our struct we declare here now, the first item here is the age. Then you go down, you copy the age, then the age will be the first item here also. So you make sure that their position are corresponding. That is, if age is the first item here, you ensure that your first item here also will be age. Then for our second item here now, our second item here is name. Then you copy your name. Our third item here is what? Date of birth. And third item here is date of birth. Then sorry, I did not write the variable name here. DOB, and date of birth, then teacher's comment. Okay, actually, so teacher's comment, maybe I mistakenly. So now our third item here is what? Date of birth. Then copy your date of birth. So just ensure that their position are corresponding. Now our last item is the teacher's comment. Then you copy it, you paste it here. Then don't forget to add your semicolon. So while we're having an error, okay, yeah, sorry, I actually copied the wrong stuff. So to paste, then our code is compiling, no error. So now successfully we've been able to successfully create um a student object from the struct we declared. Now it is time now it is time to like it now it is time to now store the data in our mapping, as I said. And now we said our mapping, the key will be, and we said a mapping just we can view a mapping as like a table where we have a key value pair. So with the help of, if a key will be given to the mapping, then we be with the help of that key we are able to fetch a any value associated with that key. Now you copy your mapping name. So now for our case now, our mapping is record, then you copy it, you go down, then so now another um another parameter I need to obtain should be the student address. So now the student address will be, so student address, student address, yeah, student student address, student address. So now we've been able to obtain our student address, then our student record now. Now it is time to store our values in mapping. So now, as I said, the syntax in which we doing that is you obtain your mapping name, which is student record. You input these two brackets, then paste the student address. So now to store a value in a mapping, you copy the mapping name, you add these two brackets. Then now, since it's a mapping of address to the student object we just created, then you copy the student address, then you obtain the new student object we just created from the struct we declared. So now, if we should look at it now, we can also say a struct enables us to, you know, to create a custom data type. So we can also look at it like that. Now, we've been able to successfully create a store student information function. So now a function that enables us to store our student information. We've been able to successfully implement it. We've done our check and all that. So now let's move to the next item on the list. So now the next item on the list is retrieve student information. So now let's now create it. Retrieve, retrieve student retrieve student information. So now function. So I'll actually walk you guys on how to create function. Also, I will be kind of fast in this section. Retrieve retrieve student retrieve student info. So now to retrieve student info, all we basically need is an address, the student address. So student address, and the function will be public, and we also know why we said this function is public. Then now we now need to check. So now we want to so now before first we need to confirm if it is the administrator that is calling this student info, and to do that we'll be using our require again. We'll be using this our require, then you copy it, paste it down here, then I require. It ensures that it is only the administrator that will be calling. It ensures that only the it ensures enforce it ensure that it is only the administrator that is calling this retrieve student info function. So now the next thing now is also we now need to check, okay, what about the case whereby the information we want to obtain have not been have not been stored in the mapping. So how do we handle that? So now the way we do that, we also use our mapping to check if. So now we also use our mapping to check if the student record is already stored there. So what's the point of obtaining record that have not been stored? Then the way we do that is now we require obtain the mapping name, we require paste, then the student address. So now guys, now we want to retrieve student information. What about the case where the student information or record we want to retrieve does not exist? So now we need to do another check to ensure that the such a student record already exists. So now, so we want to do a check that does this student record exist. So if the student record does not exist, then we want Solidity to throw an error with the following statement that student record does not exist. Now we do that to the help of our require. So now how do we do that? We obtain our student record, obtain our student record, then input the student address, then our student record, copy the student address, then check if dot age. So now I want to point our attention to something. So now in Solidity, there is nothing like null. We don't have null value in Solidity. All data types in Solidity, they have their initial value. So like now we have unit count is 0. So now if we refuse to initialize it, the default value of this count here will definitely be 0. That is now the default value for an address is address 0. The default value, so all data types in Solidity, they have a default value. So now if all data types in Solidity, if they have a default value, even without us, so all data types in Solidity have a default value even when we've not assigned a value to them, they automatically comes with a default value with Solidity. So now having this information at hand is so now we can now utilize this information. With the help of this information, we can verify if a student record have been created or not. So now, so being out so now we are now aware that all data types in Solidity, they come with a default value. So now that is now so that is now this age we declare here now, the default value is 0. So now with the help of this information, we can now check if our age is still equal to 0. That is, the record for such a student have not been stored in our mapping. So now we then access our so now we've been able to obtain our struct. So we can now access various property of our struct with the help of this dot operation. And one of the property of our struct is the age. So now if our age is equal to what? Is equal to 0, then we can now say if our age is equal to 0, then we can now say student record has not been has not been added. But so now if all dis check pass, then we can now return the student record we are interested in. So and the student record we are interested in is, so you copy it, then return your semicolon. So I done. Okay. So now in Solidity again, we also need to inform Solidity of, so now if you are returning an item in a function, we also need to inform Solidity of the type of item we are returning. So now the keyword that enable us to do that is the return statement. The returns, this one is the returns, while the one we have here is what? The one we have here is what? Return. So now the way we tell Solidity is now we now copy the data type we want to return, which is this struct here. As I said, struct also enables us to create like a custom data types. So now you copy this struct, then paste it here. Don't forget, when variables like struct, when data types like struct are used within a function, you need to specify their storage location. So you put memory. So now fine, you can see without what? Without showing an error. So now let's move to the next thing we have on the list. Let's move to the next thing we have on the list. Delete student. So now delete student. So information. So same thing. A function delete student information, then address, so student address, the address or the student information, the address of the student information we want to delete, student address, then public. So now public, then I'll require to check is the message dot sender. So you copy this. So this basically um enables us to this ensure that it is only the administrator that is calling this function. So now save message dot sender is equal to administrator. Then we also need to check if the student record we want to delete, if this record already exists. So what's the point of deleting what has not been added? So let's now verify if student record dot age, student record, so try an error. Then for us to now delete, Solidity give us a keyword that enables us to carry out delete operation. So now with the help of this delete, then you copy the name of the mapping, then the student address, so now with the help of this delete keyword, we are able to what? We are able to delete the student information. Now we've been able to create a function that enable us store student information, a function that enable us retrieve student information, and a function that enables us to what? And a function that enable us to delete information. Then also one thing is, what about if the administrator of a particular school wants to leave? So now, and don't forget, whatever one characteristics of the blockchain is that whatever code that have been pushed to it, those code you cannot change them. So that is why we need to pay extra care before we deploy any code to the blockchain. So now, what about the case in which the administrator is no longer in the school, or what about the case in which the administrator is no longer in the school? So now we need to create a function that enables us to transfer, like that enables us to change the administrator. So now you can also try to implement that in your own free time. So this will enable you to improve your skill and all that. So I will leave that for you to do that on your own personally. So but if you've done that, you can reach out to us and I can check if what you did is actually correct. So now we've been able to we've been able to build a smart contract that enables us to store student information, retrieve student information, delete student information. We'll be able to create an administrator and all that. So now, for today, this is where we'll stop. And from the next lecture, we'll be looking at deploying our smart contract to the blockchain. We'll be interacting with our smart contract, and we'll be doing a lot of fun and interesting stuff with our smart contract. So now, have a wonderful day.